Is it recording? Yeah, it is recording. Okay, it will record. Okay, so first of all, you should get this screen, right? And in this screen, first of all, we should um, create a project. Okay, we should create a project first. So yeah, we should go to project, right? Then go to project wizard, right? So you can do while I'm doing it. Okay. Right. Then we'll go next, right? Then in here we can select PIC16F84, right? I hope all of you can see this, right? Okay. Then here we should select our PIC microcontroller. Okay. So we should select our PIC microcontroller. So we'll select PIC16F84. Okay. We'll select PIC16F84. That is the microcontroller that we are going to use. And then should click next. So it will take few seconds, right? Then here the tool suits that contain in here, right? You can see it in here, right? So they will be shown in here, right? So then we will go next, right? Then we should create a new project file. Okay, so therefore what I have done is I have created, right? So let's do an example, right? So I will browse for a folder something like this. So I have a folder called MPLab example. So then example 1 LED blink, right? So start in here, right? So I will start this project. So it is called LED we'll write LED blink, right? So can you see here it is mplab project files .mcp, right? It is a project file, right? Save, right? So then we'll go next, right? So in here, right, this step we can add existing files to our project, right? If there are existing files, but here we are going to start this now, so there are no existing files, right? So therefore there's nothing to add. Okay, so then we'll click finish. Okay, now our project is created, right? Then we will go to this file, right? Then write new, right? So file, new file, right? Then we will go and we will save as, right, inside this folder. So I will show you inside this folder. So this is what we have. first, right? So this is the inside of that folder. This is the things that we have, right? So inside this folder, we will make a file, right? So I will put that file name as LED blink one, right? Yeah, I mean that LED blink one dot, right? ASM is the file that we are going to make in here is a called assembly file, right? So the language that we are writing here, it is called assembly, right? So therefore we will write it as .asm. So that is the extension for assembly language writing file that we are writing. Okay, so we will save it like this, right? So then uh, here this is our project, right? In this project I have created led blink 1.asm file like this, right? So therefore this is the assembly file. This is our project. Okay, then I need to add this assembly file to this to the source files of the led blink project. So therefore I should go there, then right click, then go to add files. Right, so here can you see that assembly file is in here. So I will select led blink one, then I will open, right? So this is the file. So if I close it, then yeah, I can open it by double click. Okay, right. Then so if you are finished, yeah, we will we have selected the file, right? Okay, so then what we will do is, so shall we do something like this? So we'll write status equals 03h, right? Then I will put end, right? So that is my program for now, right? Just writing it. Then can you see here we have make, build all, export make file. So build means actually we are compiling this file, right? So the next one is build all means, so inside this project there can be lot of um, assembly files. So therefore we can if we put this one build all, it will compile all of that, right? But now we just put make, right? So then I will put absolute. Okay, so can you see it says build succeeded, right? It says build succeeded. So then I will add port A equals 05H, right? So then by doing that also, this one also I will again. So here say build succeeded, right? So if I remove this one and will says build failed because we don't have this end, right? So okay, we will write it like this then, right? So what is next is we are interested on blinking an LED connected to port A, right? Connected to port A. So what can we do is we will try it without a delay, right? So can you remember this? Can see this thing, right? You can see this. So can you? So here BSF03H means this is status file, status register. We are clear. We are setting the bit set following to 5. So because we need to go to bank 1, right? So then we will move 0600H. Then we will make tris A here. We will go to bank 1, right? Then put all zeros to W. Then in here we will move all 0 to this A, right? Then by putting this we will come back to bank 0, right? Then here we have a label, so this is just a value, right? Then we will write this command. Then what we are doing is we will write this value to W register, which is 00010, right? So what will happen is we now that value is at W register. From that W register we will put it to port A, right? It is 05H, that is port A, right? Then from then what we are doing is so now LED connected to port A, bit number 2, which is RA1, that is switched on, right? Then we will put 0, right? Then we will put that value to port A. Then we will continue, right? Go to start. Start means in here. Can you do this example by yourself? So you no need to write 03H, right? So yeah, what are things that we need? 85H, that is this A, right? Right, so we need to define this A as well. Okay, like this we will define this A. So therefore, when you have 03H address, 05H address, and 85H address, you had to put this A port A status, right? So therefore, can you write this program? I will give you. Can you write this program in there? So can you write this code in MPLAB? So you can write this, okay? BSF 03H5, right? So BSF 03H comma 5, right? So do we have to write like this? Uh, do we have to write like BSF 03H5? No, right? Why not? Because we know what is BS03H. That is our status register, right? Yeah, for now, when we are writing, we will use all caps, okay? Or else you can use it as it is, right? 03H means status register, right? Status register. Likewise, can you see this? Okay, so this is what you should see, right? Can you all see this? Okay, this is what you should see. Need to put just put end like this, right? So can you all do this? And I have, I thought to put it as you have seen in the PDF, right? So therefore, you can do the right in as it is. And while you are writing this, while you are writing this, can you try to install Proteus as well? If you already have installed, then it's all right. If you don't have, so can you just install Proteus as well? Um, there are portable versions of Proteus as well. I have installed one like that, but it has like so since the file is installed, that has extracted like somewhat like 3 to 4 GB. So, have all of you done up to this? Are you done up to this? So if you have done up to this, you can build it, right? So tell me if you have finished. right? So if you have correctly written this, you have to make it, then it should show still executing. Okay, so it should show will succeed. So have you all done up to this, or do you need more time? I have done, right? Um, so you have asked, does it matter when you're writing capital or symbol? No, actually, it doesn't. But the thing is, um, here we are writing status in all caps. So therefore, this is a label. That is status. This is a label. So therefore, this should be same as that. Right? So if you are writing this as simple, so this should be in simple. Right? So there one have completed. So how about others? Okay, so here, so so the file registers. So we can see the register. See, yeah, this is a program memory. Um, Program memory means this is where the uh, program is stored, right? So here can you see how many lines? One, two, three, up to 9 lines we have. We have used 9 lines of programs, right? Program. So if we run it, yeah, this is what is in the program memory, right? address. We have used 9 lines of the program here. So here the thing here is we are seeing the basic version. Basic version means we are seeing at very low level. eh. So I first thought write in capital letter because this is how we can see in the program here. So that's why I asked you to write in capital letters, but it doesn't matter. It will identify whether it is capital or simple. Right. Okay. We see this special function registers. This is all zero. Yeah, this one should change. Yeah, this is not change in y because yeah, if we because sorry, in here it is zero. It should change. What table should change? Say status. Should change. Check that out. Then we have a lot of things. So we can debug, right? And here another thing is in here we can select the program. Program means so yeah, I will show that one later, right? Um, so if you have finished with this, this is Proteus, right? And this is Proteus, right? This is Proteus, right? Open Proteus. Before that, mm, I'll show you what is inside that folder. Can you see? This is the folder. uh, This is the folder, right? So if you can remember, first of all, what we had is just these we had these two files, right? And this is the file that I made, right? So here, these are the two files, this one and this one. They are the files that we called the project file, right? So then this is my assembly file, right? And here can you see that there are a lot of files that has made, right? So if I just open this LED blink, we'll open with notepad, right? Then this is my file. Can you see? This is my file that I have already written in MPLAB. Okay, you can see. Um, then what? See it. Then here we have other files. So let's see we can whether we can see this one as well. Open with. Okay, we cannot open that. Okay. Open with. Open with. We cannot open them, right? But this one we have opened, right? So this is our file, right? So after executing this one, right? So uh, first we had only these three files, these three files. But after executing, they have made these files, right? So actually, what are these files? Are these are the file types that can understand by a computer or by our microchip, right? Yeah, this one is the file that we can understand, right? And these are the file extensions that can understand by the computer, right? So when we do actual program, so these are the files that can understandable by the computer. So from that one we are choosing this hex file, right? We most of the time we use this hex file, and we need to put this hex file to our actual PIC. So let's say we have our actual PIC. PIC means the PIC microcontroller. Let's say we have that our actual PIC microcontroller. So for that PIC microcontroller, we have to send this file. Why? Because that has our program, and that should be executed. Can you understand? This has this LED blink 1.x. This file, it has our program, and it is at the understandable version of the computer or understandable version of the PIC. So therefore, we have to send this to um, our computer or our PIC, right? Or our processor, right? Or our microcontroller, actually, for our microcontroller. So in the microcontroller, there will be a processor, and that processor will execute this file. This file if we cannot understand, it can be understandable by the PIC or the processor, right? So if we go back, right, in here, uh, there's an option called programmer, and the programmer means programmer. You are asked to select. So here can you see PIC 3. So that is the most popular programmer with PIC, right? So this one actually we have to physically connect this programmer, right? We have to physically connect this programmer, right? Um, okay, PIC. PIC it. Can you see this? You can see this, right? So here, this is Pickit 2, right? So here, this one, can you see number one? That is the USB port connection. So in our computer, we have to connect our USB to here. This has the connector, right? The number one, that is the connector. So through that one, we have to connect it, right? And here, can you see this chip? So this is our Pickit. Sorry, this is our PIC 16F84 chip, right? So uh, this hex file, the hex file, it is in our computer now. So from that computer, I have to put that file into our microcontroller. So using this USB port connection, I am putting that file into this chip, right? So after putting that, I have to take it out, right? So this is the connection. Here, can you see? So you have to put this. Can you see this blue color one? So you have to put the pick, then you have to connect it there, right? Then here there's another chip in here, right? So that is not our chip, right? That is another chip. In here, this blue color one, we have to put our chip here. I will show another. Here, can you see? So in here, we have to put our pick microcontroller. Then we have to connect it to the computer. Then we have to put that hex file inside this, right? Inside this. So we have connect connected to computer. I just, yeah, we don't have. So here, this one, this is, yeah, yeah, this one. Can you see this? This one. This is Pickit tree, right? Pickit tree. So this one we can directly connect, but that is the important one. This one, using this one, we can understand, right? Yeah, this one we are connecting to our computer. Then we will put our hex file inside this PIC microcontroller, right? So in order to do that, we can use, in order to do that, we can use this. So here programmer, select programmer, right? We have to select PIC3, right? So here if PIC3 is connected, it will show, right? It will show, but here PIC3 is not connected, right? So I haven't connected one. So therefore it will show. So using this MPLAB, we can select that hex file and we can put that hex file inside our uh, microcontroller, right? So it will act as a GUI for that, right? Okay. So after running this, so this has built, it is successful, right? So build is succeeded. Then um, you should open um, Proteus. And then from Proteus, here you have to choose the component mode. So here there are different modes: junction dot mode, via label mode, text script mode, buses mode, sub-circuit mode, terminals mode. So likewise, uh, mm, terminals mode, sub-circuit modes, buses mode. So like that, there are a lot of options. We have to select go for this component mode, and in component mode we have to go for a pick from library. So here L means library manager can both do. So we can go for pick from library. Pick from library. Then if you can remember, we just need to pick 1684, right? So here this one. So just select it. Then if you double click that one, it will be added in here. It will be added in here, right? And also with this one, I need resistor, right? I need the resistor. For double click, that will be also added. Then I need an LED, right? So I will select an LED here. Animated LED yellow. I will select. Okay, so double click, it will add in here, right? So then here this pic 16F84, right? So which port that we are connecting? We are connecting to so I will switch on and off LED connected to port A, bit 2, right? Bit 2 means RA1. That's how we have written our program RA1. So that is RA1 in here. So I will put this resistor, right? So the most probably that the register that resist that we are using, it is like 330 ohms or 270. Right? So we'll put 330, right? Then this is our LED, right? LED. So now we just need to click and we just need to click in the space, right? So then we just connect. Then here terminals mode. From terminals mode, we have to select ground and ground. You have to connect, right? So now the circuit is completed. So when we have a signal at RA1, this should light, this should switch on and switch off, right? Um, thing in here is here, can you see that processor clock frequency? Clock frequency means it is 1 megahertz, right? 1 megahertz, that is a processor clock frequency, right? So let's say it take like it will take like 4 clock pulses, uh, 4 clock pulses to execute one. So that means it is 104. That means 250 kilohertz, right? 250 kilohertz means 1 megahertz means it is 1 microsecond. So it will take like 4 microseconds, right? So that means it should not show us this LED blink, right? But the thing in Proteus is it will show this is not the real diagram, right? This is not the real diagram. This is the um, what we call this is just a simulation diagram, right? So therefore it will show this is switch on and switch off, right? So then here can you see next one, this one program file, right? Program file. In that program file, we have to, so you there's an option to select, right? So go to open, right? Then next is our example, say yeah, example on LED blink, right? From there we need to select this hex file. So since this is a simulator, we don't need to connect it, right? Connect, pick it to, so that is the actual way, right? So this is our normal way. Normal way means this is the simulation method, right? So either way, I need to put this hex file inside our pic, right? So this is inside our pic. So I will select this, double click, okay. Right now, our hex file that is inside this pic. Okay, can you understand? Our hex file is inside this pic, right? Then, so now it can be understandable by our pic microcontroller. So then we will start. Yeah, can you see? It will blink, right? So for actual case, this should not show us this, right? Why? Thing is, it should not show because the time difference between switch on and switch off is very less. So I have told you previously, when we don't have a delay, what is happening, right? So I'll stop. Then I will put like something like, let's put 16 megahertz, okay? Then also it will show, right? But the thing is actually it should not show in actual case, right? It should not show in actual case. So now we have made our program, then we have tested it on here, right? So I will just save design as LED. I will use same, so you don't have to use same name, right? I will just use it. Link one. Right? It is design file. Right? Design file. I will save it in there, right? Then any questions? Any questions regarding this? This is how it looks like, right? So the we can change anything, right? Why we are using this resistor? So you know that when there's a current flowing through an LED, let's say this will act as a diode, right? So there will be like very less or actually zero voltage drop through this LED. So if there are zero voltage drop, then we are like short circuit in RA1 pin and ground. That means when there's a voltage on RA1 pin, there it will be very high um, short circuit, right? So therefore, we are not going to do that. Then here, so are you able to open this Proteus? So no. Okay, then what we will do is yeah. Questions. Okay, so this is our delay loop, right? So you can write this one, right? So in few minutes you can write this. Then right. So why I'm asking to write this, so you will understand each line by line. Then you will write it, right? So if you have that this one, you can write, or otherwise, so you can write this program in here. So what we can do is. So file new, right? Then file save as LED link to, right? And we need to put dot ASM, right? For sure. Then we'll save it. Then go to source file, then right click, then add files, LED blink 2, because LED 1 is already added. We'll open, right? So now we have, so let's say if we close this one also, this, right? So in here, right? Can you write this? So understand line by line, then you can write it, right? With delay loops and um, the labels. Right? So we'll write this one first. We'll do this as example number 2. Okay. right? I will move like this. Okay. Mm, HU. Okay, can you see this now? Like this. Yeah, so I was muted, right? So here, when we have two source files, LED blink 1 and 2, it will execute 1 and 2 both. So therefore, what I have done is I have removed LED blink 1, right? Then this is what I have. This is the file that I have copied from there, right? Then I will just run it. Okay, so can you see that it will be succeed? So have you all done up to this part? So we can continue. So now, have you all completed this? You need more time. So that program I have written it in here, right? Okay, so then we check again in here. Can you see the text file, right? Yeah, can you see the hex file in here, right? So now um, you can see this hex file. You can see the hex file, right? Then you should go to Proteus, right? Then in Proteus, select LED blink 2 hex, right? Open. Okay, and let's run it. What is actually working? Previously it was not working clearly. So let's put like 1 megahertz. Okay, now it responds. Can you see? Now it responds because when there is no delay, it is not responding correctly. So here, can you see that delay? On, delay, on, delay. Sorry, on, switch on and delay, off and delay, on and delay, off and delay. So like that, it will continue. Like that can do. Anything you need to ask from me? Anything you need to ask from me uh, regarding this? In here, actually, when we don't have a, so let's say we have to stop. So now it is actually working, right? Not like the previous one. Let's put like 64 megahertz. Now what is happening? Either way, so it is working now, right? So uh, when it doesn't have any frequency, it is not working as it it should be, right? So here, so you can try these kind of things, right? So you can see here we have a delay loop, right? Loop one and delay loop two, right? So if I summarize what I have done here, so when we execute this, when we compile this, there's a hex file, and that hex file you have to put it to the PIC microcontroller, right? So we have done it using Proteus, right? So therefore, after putting that file to Proteus for our PIC, to our PIC, we can run and simulate. So the same thing will happen when we are doing it in actual world. So in order to do that, we need PIC2, right? And PIC2 or PIC3. So using this program, you can program it as necessary. And here it doesn't have PIC2 now. And so like that, you can try. Um, any questions? Any questions? Okay, so if you don't have any questions, we'll stop for today, right? Sharang, okay, I will send the previous lecture note. So for this one, actually, I don't have a lecture note. So this is the practical work that I have done today. Okay. So here